Hi, I'm going to solve past paper 4, May-June 2018, variant 2. Let's start. Question 1. A figure 1.1 shows the axis of a distance time graph for an object moving in a straight line. On figure 1.1, draw between t equals 0 and t equals 10 seconds the graph for an object moving with a constant speed of 5 meters per second. Start your graph at distance equal 0 meter. Okay, how to solve this question? Here at the beginning we want to draw a straight line from t equals 0 to t equals 10. So we have here the speed equal 5 meters per second. This means that the gradient g equal 5 meters per second, and the gradient can be identified by the equation delta d over delta t over delta t equal 5. So here we can get the equation. So we have here d equals 5t. At t equals 0, d equals 0. This is the first point, 0 and 0. And at t equals 10, d equal 50. So it's equal 50. Okay, so we need only 2 points to draw this line. So the first point is 0 and 0, and the last point is 10 and 50. So here is the first point here, and the last one is 10 and 50, so it's 0. It's half distance between this. Okay, this is a straight line. Okay, let's take the property of the graph that represents the speed. So the graph here is a straight line, so we can describe it as a straight line. With gradient equal 5 meters per second. Next point, between time equal 10 seconds and time equal 20 seconds, the object accelerates. The speed at time t equals 20 seconds is 9 meters per second. Calculate the average acceleration. So I have here the speed at t equals 20, which is 9 meters per second here. So here this is v equal 9 meters per second. And we need to find the speed at 10. The speed was 5 meters per second. So we have here the initial speed is 5 meters per second. U is 5 meters per second. So we can get the acceleration A equal V minus U divided T. So we have here V 9 minus 5 divided the time taken, which is 10. So we have here 4 over 10. So the acceleration is 0.4 meter per second square. Next point, figure 1.2 shows the axis of a speed-time graph for a different object. Okay, the object has an initial speed of 50 meters per second and decelerates uniformly at 0.35 meters per second square for 100 seconds. Draw the graph represent the motion of the object. Here again, he wants us to draw a straight line to represent the deceleration. So that this straight line starts from the point 50 on the y-axis. So here I have to draw the equation of the straight line. The equation of the straight line like this. So y equal 50 minus 0.35 x, and y here is speed 50 minus 0.35 t. This is the equation related between the v and t. So here at t equal 0, v equal 50. So the first point here we have 0 and 50. Okay, then at t equal 100, I need 2 points. So I took this point to be the first, and this is to be the next. V equal 50 minus 0.35 times t, which is 100. So we can get here V equal 50 minus 35. We can get V here to be 15 meter per second. Okay, so the next point is 100 and 15. 0 and 50. This is the first point here. This point. And the next point is 115. So we draw the straight line between these 2 points. Next point. Calculate the distance traveled by the object from t equals 0 to time equal 100 seconds. So we want to calculate the distance. So this is the speed time graph. So we have to calculate the area under the graph. Okay. So let's get back to the graph again. So we have here this shape like this. So the area of this graph. Okay, we need to calculate this area. So we have here to find this area. This side is 15, and this side is 50, and this side from 0 to 100 is 100. So the area of the shape equal 50 plus 15 divided 2 multiplied by 100. So the distance here equal 50 plus 15 divided 2 multiplied by 100. We can find it to be 3,250. So when we round it, we can find it to be 330 meters. Okay, this is the first question. Thank you for watching.